Hi, and welcome back to the last lesson in week 3. Here we're going to talk about deadline delays and how driving performance actually reduces it when it comes to task durations. So I want to give you a scenario, one that probably many of us experience if we've ever had to travel home. In this case, I'm going to be driving home later. And the question is, when am I going to arrive home? And the reality is that I don't know. I can guess, I can look it up on Google, but the reality is that there are many things that could happen on my way home that might change when I'd arrive. Meanwhile, I've driven home hundreds of times, thousands of times, and I know this route very well. But at the same time, I can't accurately predict exactly when I'm going to arrive. And that's because I might decide I'm going to speed through all the lights, at which point I'm just going to blow through them and I'll get home really fast if I don't get a ticket. Second, I might get all the green lights. If I get all the green lights, I'll get home in about 60 minutes. I know it's a long commute, but I live in DC. Third, I might get all red lights. If I get all red lights on my way home, then I'm going to have significant delays. It will take 90 minutes to get back. Or maybe I get into an accident or break down. In that case, it's going to take me maybe 2 hours to get back because of all the paperwork. Or on my way home, I could get distracted and my buddy might call and say, "Hey, John, let's go grab a drink and watch the game," at which point I'm not getting home for hours. All of these things could happen. And in fact, it's very similar to what happens to us on our projects. We get lucky, we break the rules, we don't get lucky, something bad happens, or we get really distracted, which is almost always the worst. In these cases, we have to be aware of the fact that this happens. This is life. This is natural task variance. To understand that in a little bit more detail, let's go to the next slide. This slide shows what's called the task variance curve. What it's showing for you is the probability distribution function, which is the likelihood that a task will complete at that point in time. What I've marked for you on this graph is what's called the cumulative distribution function, or the likelihood that a task will complete by that time. So if you look here, it's actually a long tail distribution, which means that the most likely outcome is actually very low, but then there's this long tail of bad things that could happen or delays that could happen, which could mean that one task gets dragged on for hours, days, or never completes at all. And the thing is that we know this really well. We don't need a distribution function in order to understand our tasks, but we do know very well that it can take a long time to complete something if things go wrong or if we get delayed. So what does this mean? What do we do naturally as humans when we're asked to give a deadline on a single task? We buffer. We buffer so much that oftentimes we will double the estimate of what it will actually take to get something done. And because of the fact that we double it in order to get kind of the 80-20 amount of time, we are adding significant delays to the actual project because all of our tasks are 2 times as long as they should be. And then we wait until the end in order to get started. So when you combine this with the previous delays, it runs into significant overhead on a project because we want to put schedules and deadlines on every task. So in summary, we need to keep in mind that task estimates are just that. They're estimates, they're guesses. And there are many conditions that could happen so that we finish early when we expect to, or we can be significantly delayed. In addition to that, task deadlines are naturally things that we buffer against. We don't like to be late. In fact, being late is something that we have a stigma against. So as a result, if you ask me on Monday if something is when I can get something done, and I know I can get it done by Wednesday, I'm going to tell you Friday because I'm worried something might happen. What does that mean? It's taking twice as long for you to get it. And that's the reality. We are more likely to double the estimate so that we can make sure that we deliver on time rather than be honest about how long we think it's going to take and admit that we may not be able to deliver on time because of the fact that we have a deadline. And that's the deadline driving these delays. So in the end, this is a form of waste that we want to avoid. And if we can avoid it, if we group tasks together into a single time box and we remove the deadlines, get rid of the deadlines. We're going to talk a lot more about that in week 4, but this is the final and probably the most impactful form of waste when it comes to task estimating and scheduling in general. You can go a lot faster than you're going right now, and the way to do that is to take out the schedule. We hope you've enjoyed this lesson and the previous lessons in week 3. We look forward to seeing you in week 4.